Question 2 says two horizontal plates are separated by 1.2 times 10 to the minus 3 meters, are connected to a variable power supply. The plates are used to levitate different objects on Earth. State which plate must be positive and the required voltage to levitate various different things. So if we're picturing what's going on in this situation, we're going to have the weight of the object acting downwards and an electrostatic force acting upwards, and we know the size of the electrostatic force is the electric field strength times the charge, or V Q over D. So we want to set VQ over D equal to mg in each case, and then we're going to be finding V. So we'll do the rearrangement for the first one. VQ over D is equal to mg, and therefore V is equal to mg d over q. So in each of these calculations we're going to need to put in the correct values for m and for q to work out what V is. So in the case of the electron, its mass is 9.1 times 10 to the minus 31 kilograms, and its charge is 1.6 times 10 to the minus 19 coulombs. So V is equal to 9.1 times 10 to the minus 31 times 9.81 times 1.2 times 10 to the minus 3, that's the separation of the plates that we have up at the top, over the charge, which is 1.6 times 10 to the minus 19 coulombs. So when we calculate this, 9.1 times 10 to the minus 31 multiplied by 9.81 multiplied by 1.2 times 10 to the minus 3 divided by 1.6 times 10 to the minus 19 gives us the so that's 31. Let's get that correct. Gives us the voltage required is 6.7 times 10 to the minus 14 volts. For a proton, it has a mass equal to 1.67 times 10 to the minus 27, and its charge is also 1.6 times 10 to the minus 19 coulombs. Sorry, I paused slightly because I've missed this bit, haven't I? State which plate must be positive. So for an electron, we want it to be attracted up, so top plate is positive on this one. For the proton, for it to have a force upwards, we need the top plate to be negative, or alternatively the bottom plate positive. Sorry, this is just a shorthand way of writing positive that I've used up here. So equation for this one, V is equal to the mass 1.67 times 10 to the minus 27 times 9.81 times the separation, which is 1.2 times 10 to the minus 3 over 1.6 times 10 to the minus 19, which gives us a value of 1.67 times 10 to the minus 27 multiplied by 9.81 multiplied by 1.2 times 10 to the minus 3 divided by 1.6 times 10 to the minus 19. 1.23, sorry, so we're just going to write 1.2 times 10 to the minus 10 volts. Then next we've got an alpha particle, so let's use another colour. Its mass is 4 lots of the mass of a proton, and its charge is 2 times the charge of an electron, but positive. In terms of the plates, we're going to want them the same way round because this is also positive. So V should equal 4 times 1.67 times 10 to the minus 27 times 9.81 times 1.2 times 10 to the minus 3 meters for the separation over 2 times 1.67 times 10 to the minus 19 coulombs. As we look at this, we could do this calculation. We could probably also spot that it's the same as the calculation that we had last time inside here, but with this factor of 4 and 2 at the start. So this is just going to be double what we had last time round. So 2.4 times 10 to the minus 10 volts. The last one, a hydroxide ion. Again, we'll use a new colour. So the mass is going to be made up of oxygen and hydrogen, one oxygen, one hydrogen. So our oxygen, we're going to say, has a mass of 16. Our hydrogen, a mass of 1. So we've got 17 lots of 1.67 times 10 to the minus 19. Because it's the whole atom, we might use 1.66 as a better value, but I wouldn't worry too much about which of the two we use. If you looked up the mass of the hydroxide ion, that's fine. Its charge is minus 1 times the charge of the electron, so minus 1.6 times 10 to the minus 19 coulombs. Because it's negative, we're going to want the top plate to be positive. And again, the voltage then is still equal to mgd over q. So we've now got 17 times 1.66 times 10 to the, sorry, this should have been 27, times 10 to the minus 27 kilograms, times G times the separation over the charge. That's 1.6 times 10 to the minus 19, and just calculate that value. So 17 times 1.66 times 10 to the minus 27 multiplied by 9.81 multiplied by 1.2 times 10 to the minus 3 divided by 1.6 times 10 to the minus 19 gives us a value of 2.07, so 2.1 times 10 to the minus 9 volts. Oops, daisy. Volts.